So I thought I'd kick off this morning with just a 2-minute clip that I wanted to thank Amber and TJ, if you'll raise your hands right there. You get a kick out of this. Some of you may have seen this already. See if I can do this right. Of course not. Thank you, guys. I always like that. A lot of those views on there are mine every once in a while. Let me unhook from here. I think I did that right. Second thing I wanted to do before we kick off is thank a number of people. Like I mentioned, TJ and Amber for putting that together, and also thank a lot of the people who made this seminar, research seminar, possible this year. First of all, the people who put together and spent all the time submitting the abstracts, going through the jury process, putting together their papers, and then spending the time on top of writing the papers, putting together their presentations. So it's been absolutely terrific. Looking forward to today. And also wanted to thank all the plenary speakers and the folks who have who will be volunteering this morning for this session, and also for the panels from yesterday. That was terrific. Wanted to thank some of the research donors, Kelly Allen and Fred Warmbier, who donated money to help with some of the scholarships, and then in-kind donors, Stephen Hadrick and his team, for the gorgeous folders that are sitting in front of you. Those were printed by Stephen and his team. Thank you very much. And TJ and Amber again for the terrific conference schedule that I've seen a lot of you using on your iPads, iPhones, Androids. That was terrific, and look forward to, they've offered to do that next year too, and even at a deeper level too. So that is fantastic what they've been able to do. And then the other donors, are some of them anonymous sitting in here, who contributed to the scholarship fund that enabled us to invite a number of different people here. Thank you very much. And then lastly, I wanted to thank everybody that volunteered to help, all of the different session chairs, scholarship committee, those who reviewed the papers from the jury. I know that was a lot of time, and there was feedback that was given to a lot of the presenters that they found very helpful. Appreciate all the time that they did, and the other event volunteers, because this would not have gone off without all the volunteers that we do have. And especially want to thank Darlene and Ken, who are in the back. If you guys raise your hand, I'm sure you guys have seen them. I've had a couple people come and saying, man, you put on a great conference seminar this year. I was like, it's not me, it's those guys. They were the ones that did all the heavy lifting and all the scheduling and everything. So it's been pulled off incredibly well. I know it's very challenging to do these type of things. So thank you guys so much, deeply appreciated. And the last thing I wanted to say is that when I talked yesterday morning kicking off, we were talking about learning and the ways people learn differently. And that's part of what we are doing right now, is trying to create these different options for you within the event so that you can learn. But the best we can do in an event like this is create that interest, create that awareness, create that curiosity in wanting to learn something more and at a deeper level. And part of what we're doing as an institute is providing that opportunity to learn at that deeper level. And one of the things along those lines is a 4-day seminar that we have coming up April 27th through 30th in Columbus, Ohio. And I encourage you to try to attend that. It's up on the website right now. It's going to be a tremendous deep learning experience. And Hero Hackaboard will be one of the facilitators. For those of you that have your copies of the New Economics, as you go through it, you will see Hero's name interspersed throughout the book, as my grandfather relied on him and quoted him several times in the book. Also, the other one, a facilitator, is Gordon McGilton, who a number of you have had the opportunity to meet over the last day or so. And I'm going to have Gordon come up just for a minute and chat just for a couple minutes about the 4-day seminar and what we're going to be talking about in Columbus, and hopefully you have a chance to ask Gordon some questions. Kelly Allen's also working with us on putting that together. You can talk to Kelly or to me about that, and any questions you have, please let us know. So, Gordon? Gordon and I, one of the things we do have in common is in the last couple of years we've both been hit by trucks. I'm looking a little better than he is right now. I don't have to walk.
In addition to that, I say if I'm going to be a target, I should look like a target. So I wore this tie. Well, my esteemed consulting partner, Hero Hackaboard, is a genius. Dr. Deming sponsored his immigration from South Africa to the United States back in 1980. Hero invited Dr. Deming to go to South Africa and try to help the people in his country, learn about profound knowledge and take advantage of it to improve the standard of living for the people in South Africa. Dr. Deming gave him what his conditions were. He had to get all of the top people together in one room, and the standard things that Dr. Deming always would prefer to have. Hero went back, and in earnest he tried to do that. He talked to everyone. He put a great deal of effort into it, and he was unsuccessful at being able to make those arrangements. Dr. Deming came anyway. When he got there, he saw the people that were there. He saw Hero work. He began to understand what Hero knew. And how many people have seen the red bead experiment? Okay. At the end of the red bead experiment, when you do the lessons of the red beads, do you see the formula that Dr. Deming uses? Okay. That was not the formula that he originally used. He used a different formula when he did the red bead experiment, up to the time that during one of the seminars, Hero was sitting in the front row, as he always did, because he's an unceasing learner. You never told Dr. Deming he was wrong, but it was always okay to ask a question. Dr. Deming, based on the type of data that's being produced, wouldn't this be a better formula? Dr. Deming looked at the small piece of paper. He said, "Oh, Hero, you're so right. I shall do so in the future." And so from that point forward, that gives you some sense of how smart Hero is. And he had an ability to, even to a genius like Dr. Deming, to be able to contribute and demonstrate that he knew some things. And Dr. Deming, on videotape and in person, often referred to Hero as a master consultant. When Dr. Deming passed away in 1993, Hero and I were both brokenhearted. I, just as a student, but Hero, as a peer and someone that got to work with Dr. Deming, we couldn't we couldn't imagine the idea that this information was no longer going to be available to people. The power of this, when I got it, it didn't change my life. It changed who I was as a person, but it gave me the ability to change my life. I couldn't imagine that that wouldn't be good for other people as well. So since Dr. Deming died in 1993, about 2 years later, Hwarng and I began doing 4 days. First we attended the events that were intended to try to continue forward and continue spreading the word. And our observation was that why would we try to improve on what Dr. Deming did? We could still get Dr. Deming. He would make guest appearances at a seminar if you held one. He'd show up all day, every day for 4 days. Why didn't we just keep inviting him? He was on videotape. And we concluded we couldn't improve on his 4-day seminar, so we've continued to do his 4-day seminar all over the world. I think we may have done something that approximates 1,000 of them now. We do it for big clients, and we've done it in United Kingdom and all over the world, and that's what we hope to do again in Columbus, Ohio. So we've never stopped doing the 4 days. We haven't tried to improve on it. We haven't tried to edit it. And our belief is if you can take 4 days or 5 days and go to Ireland to play golf, you should be able to take 4 days to learn how to run your business in a better way, how to run your hospital in a better way, how to run your school in a better way. So we just continue to do the 4-day, and we've never had any trouble filling the room. Never had any trouble filling the room. And so that's what we hope to do again. We generally haven't done public seminars, not that anything was private, but this is going to be a public seminar. Anybody that wants to come can come, and it's going to be as close as we can make it to the 4-day seminars that Dr. Deming did when he was alive. The only thing that changes is the facilitization in between the videotapes, but it won't be you sitting in a room just watching videotapes. The other thing we do is we go to the trouble of visiting the enterprises of the people that will be attending, not all of them, but as many as we can get to. And then when we do the facilitization in between, we try to attach it to your personal business. So the examples we will use will be coming from the businesses of many of the people that will be in the audience attending. And we've learned that attachment and making it real, taking it from an academic perspective to your real life situation is really important. So we'd love to have you come. We'd love to have you send other people, educators especially, business owners. So if you have the time, or if you have someone that you'd like to give a gift to, this would be a great gift.
Next, we're going to kick off with Brian and the funnel experiment. This will be fascinating. I'm going to turn it over to Kelly to introduce the event, and we can go ahead and kick off his session.
Good morning. Before I introduce Brian, I wanted to give you a little context. So the research seminar is, as you have already experienced, is a blend of folks who are new to Deming's teachings and those who are experienced in Deming's teachings who are coming back to learn more, to go deeper. And so that sometimes sets up an interesting dynamic because those of you who are new probably feel that we've just been spraying you with a fire hose. PDSA, System of Profound Knowledge, Deming Management Method, 14 points, 7 deadly diseases, et cetera, et cetera, et cetera. But you've hung on for the ride pretty well, so we're going to hit you with another one just to expose you. And it's pretty interesting what we're going to be doing. There's the famous 4 rules of the funnel that Dr. Deming also talked about to help people understand a variety of things of his philosophy, including understanding variation and why constantly tampering and moving things actually makes things worse than really understanding and learning the capability of your process or the system that you're working in. So about 4 years ago, I had the honor to meet Professor Brian Hwarng from Singapore. I happen to be in Singapore on behalf of the Deming Institute, and those of you who know the expression, there's no such thing as a free lunch, well, he came for breakfast. Poor guy. He's been paying for it ever since because he has been giving so generously of his time to the Institute. We hope sometime in the next few months, Dr. Deming's books will be coming out in Chinese. And that's especially important because a lot of Chinese executives come to the National University of Singapore, where Brian is a faculty member, to study with him in the MBA program. And they come in expecting to learn about traditional management, and what they get is Dr. Deming. So they're very excited to leave, but many of them don't read English quite so well, so we've been trying to, not only for this reason, but for many reasons, to get Out of the Crisis and the New Economics published in China again. And so Brian's just, we couldn't have gotten this far. It's been a long journey. We're almost there, but we would have had no hope of making this happen without his help. I don't want to cut any more into his presentation, but here's what we're going to do. You will be receiving an email with his presentation and with what we're videotaping here this morning. So you can combine those things, and with his list of credentials, which are about this long. So I think he was born in Taiwan, lives in Singapore, got his PhD from Arizona State University, has also done stints at Harvard and elsewhere. And when he's home, he flies from Singapore here and then back, and he has no jet lag. I don't quite understand that, but the other thing that's happening here today is he proposed this paper of looking at the funnel experiment in some ways that are not only demonstrate variation, but also demonstrate 14 points, system of profound knowledge. So when we were talking about this, I sent his paper up to Dr. Joyce Orsini, who also worked closely with Dr. Deming, to have her really look at everything as a part of the jury, because all of you had juried papers. And she wrote back and said that she would be sorry not to be able to come and see it because she thought it was going to be really, really interesting and spark a lot of conversation. And Brian, being a true lifelong learner himself and being a true an academic, but also a practitioner. He's done engineering. He's done all kinds of things before he went into the university. He wants your feedback. He hopes to, because this is the first time, not only in the United States, but anywhere, where he has been able to pull it all together for a group that wasn't a group of students. So this debut, so he's sort of performing without a net. But he has some willing workers to help him. So would you join me in welcoming Dr. Brian Hwarng from Singapore?
Okay, it works. Great. Thank you very much, Kelly, for your kind introduction. As he said, this is the very first time that I will be doing it. I've never done this before, although I have conducted the experiment with my students for more than 10 years. But this is the very first time I consolidate all the data that I collected and try to show how we can develop a deeper understanding of Dr. Deming's 14 points and system of profound knowledge from this experiment. And I would first like to acknowledge those willing workers, Stephen, Laurie, Tripp, Prony, Diana, Shirley, TJ, Amber, and Gina. Would you like to come on stage now? Let's welcome them. And Stephen, your team will be designation Team A and sitting on the far side. Okay. And Pernie, Dana, Shirley, Team B in the center. TJ, Amber, Gina, close to my end. And since they already run through this experiment overtime yesterday, they are really willing workers. And I'm going to ask them to just go ahead to finish the experiment while I'm explaining, so that by the time I reach the point, they will have data to show us, okay? So guys, you just go ahead and do the experiment, follow the instruction that we had yesterday, okay? And finish all the 30 bins. So while they are doing it, okay, please make sure you follow the rules strictly. Then I'm going to begin my introduction here. Perhaps not all of you are familiar with Singapore. And in case you don't know, that would be, right, the dot, a little dot there. But something you might like to know is that there is a breaking news just happened in the last couple of days. That is the passing of Mr. Lee Kuan Yew. So I also take this opportunity to show my respect and mourning. Although I'm a foreigner, today I'm still a foreigner in Singapore. But over the past over 20 years, I indeed witnessed this country, how it evolved, advanced. As President Obama commented in this statement that I'd like to draw your attention to is that Mr. Lee Kuan Yew's insights on Asian dynamics and economic management was respected by many around the world, and no small number of this and past generations of leaders has sought his advice on governance and development. This is really, really tied very well with what we are going to talk about today. It is because of his insights on the economic development and governance that made this little country to become what it is today and so competitive. And it is because the leaders of the country governed this country as a system, just like what Dr. Deming taught in the new economics for education, for industry, for government. And I can testify that I am in this education institution, National University of Singapore, as a faculty member, as a foreigner, and I can testify, I observed that over the past over 20 years. This government as a system practiced a lot of principles that is taught by Dr. Deming. So which is of the Dr. Deming's 14 points, it is the most difficult to be appreciated, in your opinion or in your experience? Anyone would like to share? Which of the 14 points? Dennis?
I think the most difficult to understand from many of my customers is the point about not evaluating, rating and ranking.
Which point? Point?
I don't remember the number.
Kelly would know, right?
No, I'm going to say point, drive out fear.
drive out fear, okay? And then it's referring to point 11. I would certainly agree. These probably are two of the most difficult points to get people to appreciate it. Therefore, why did I do what I did now? It's really because that over the years when I try to teach these principles to my students, and they are mature students, right? Most of them will be MBA or executive MBAs. Their age could be from 30 to 60 over. But after I share with them the 14 points, and often their comment is that this is not relevant to the business of today. It is too idealistic. It almost like for those students from China, they thought that it almost like a communism, ideal state of a society. It is impossible in today's business world. And I have been trying to think, how can I show them that it is not the case? And when I introduce this experiment to them and do what they are doing it now, and students will have further questions. They will say that, well, can you make the experiment easier? For example, you can provide us a holder for the funnel, or even try to automate the process so that it would much more time, less time consuming, and we can collect the data in a much shorter time. But I told them that would defeat the purpose of the experiment. The very purpose of the experiment is to incorporate these different elements so that I can show the dynamics, I can show the complexity of the real world. For those of you who are not familiar with the funnel experiment, the original funnel experiment, the purpose is to demonstrate by theory the losses that are caused by tampering. And that we see that every day in any organization. That is management by results, management by objectives, by mere figures. And in the original funnel experiment, look like picture, right? You have a funnel, and you have one marble. A marble will fall through the funnel, and you have a table with a cloth or something that will prevent the marble from rolling too fast. Then you have a holder for the funnel. That is the original funnel experiment, okay? And the procedure is that you're going to indicate a dot on the tablecloth as the target, then apply one of the rules. In Dr. Deming's original experiment, there are 4 rules there. So you apply one of the rules, and you drop the funnel through drop the marble through the funnel. Then you mark the spot where the marbles comes to rest. Okay? Then you continue through 50 drops using only single marble. Now, I'm going to change this to what they are doing it now. And we call it the expanded funnel experiment. The idea of calling it the expanded funnel experiment, it is after my discussion with Kelly, and then I thought that this will sort of distinguish something additional that we're going to anticipate or learn from the experiment. And the purpose is, in addition to demonstrating the losses that are caused by tampering, and we're going to also physically demonstrate each of the 14 points and the system of profound knowledge. And what are the additional elements that we introduce to this experiment? The funnel now will have different sizes. So I have 3 different sizes of the funnel: large, medium, and small. And each funnel is attached with a string with different lengths, 30 cm, 26, and 17. Don't ask me why they are so. It's just when I first started, I used this. And now I have to continue to use this so that my data will be consistent, okay? But those are reasonable length, okay? Then they have a target. Perhaps some of you can show them. The target, one is circular and the other one is oval. That means that there are two different dimensions of the targets. And target, you can imagine, is just like specification provided by your customers or clients. So you have different type of clients, right? And the funnel will be your system. The string, the height, that will be how you operate it, right? So we are seeing a very complicated system now. And they are each given 30 bins. These are pre-allocated 30 bins. Today I'm using red bins, right? And each bin has different shape, right? And different dimension, although they are all from the same lot of the bins, right? Then I provide a transparent plastic ruler for them, easy for their measurement, and a record form. There's a record form to record the distribution of the outcome, okay? Now the procedure is that we have 3 members in each team, then each play a role as the funnel holder or the bin releaser or the hit spot recorder. Someone is going to record the hit spot. That is not an easy job, right? Because the bin hit the paper and very quickly, instantaneously, you have to record it. You need to have very sharp eyes to do that, right? Then each team, as I already explained, have a different set of instruments. Right? Therefore, there are 6 different combinations. As you can see here, funnel, LMS, large, medium, small, and target circular or oval, and the height, 30, 26, 17. So all together, 6 combinations. Right? Now the procedure, going to apply Rule 1, Rule 2, Rule 3 in my typical class. Students will do all 3 rules. But for demonstration purpose, today, actually, each team is doing a different rule. So we have Steven's team, Team A. What rule did you apply? 3. They apply Rule 3. They have large funnel and Rule 3 and circular target. And Team B, what rule did you apply? Rule 2. And they have medium funnel, right? And also the circular target, right? And TJ, which rule did you apply? Number 1. Rule 1, they apply Rule 1, okay? And they have small funnel, and they have the oval target. Their target is the biggest one, but their funnel is the smallest one. Now, you can probably anticipate what kind of distribution of their bin drops, okay? Now, Rule 1, you're going to draw a bin from the container and drop it naturally. You don't want to exert force or aiming at the center of the hole of the funnel. You want to let it just slide down along the rim of the funnel. Then you're going to mark the spot where the bin first hit the target, the first contact point, not the rest point, the first contact point, okay? Then continue about procedure, draw, drop, and mark until all 30 bins are done. They are each given 30 bins. Then summarize the distribution of the 30 spots in the record form. Then repeat the experiment applying Rule 2 and Rule 3. And going to do this. The actual experiment, when I do with my students, it will take probably close to 1 hour to finish all 3 rules. And each team will do all 3 rules. But today, we just ask them to do one of the rules, right? Okay. Now, I'm going to ask them to share some of their experience. Yes?
Are the beans the same size?
No, different. They are of the same group, but the size are about the same in a certain range, but each one is unique. Shape is still the wrong shape, right? They are of the same species, though. Yeah, so they are similar in shape and size, but each one is unique. Just like what you can get in the grocery store, right? All the beans, they are similar but different. Okay. The purpose of this is to better understand variability, and to identify common and special causes, as the original experiment taught us, and to understand the serious consequences of tampering. That means the wrong decisions due to a lack of knowledge of variation. And we saw that every day. We see that every day in the organizations. On top of that, this particular expanded experiment is to illustrate Dr. Deming's 14 points and system of profound knowledge. And I think this is very powerful. And this will be a typical setting in my classroom, right? And as you can see, funnel of different sizes and string of different length. And they're going to do this, rule 1 and rule 3 and rule 2 and rule 3. And rule 1 will be just aim at the funnel, at the target, and you don't move the target throughout, right? So your funnel aiming at the center of the bullseye, and you don't move the funnel. You maintain the constant height according to the length of the string. And you do it, repeat it for 30 beans. Very straightforward and simple. I think Team C, TJ's team, has the privilege to work on this rule, right? Easiest rule. Okay, rule 2 is a bit more complicated. And Peroni's team happened to be assigned this rule. At each drop, you move the funnel from its last position, right? Last position. To compensate for the last error. Error refers to deviation from the target. When you see the deviation from target and consider that as error, therefore you want to adjust your system to compensate for that error. For example, it begins with funnel aiming at the center of the bullseye, and suppose the first bean dropped here. That means the deviation. This is the error, right? So you're going to make adjustment in the opposite direction from its last funnel position. So the new funnel position will come to this place. This will become the new funnel position, right? Then when you drop the second bean, and it drops here, and you measure the deviation. And you're going to do likewise. You're going to adjust to compensate for the deviation that you observe, not knowing that your funnel is at that location for some reasons. Not necessarily, correct to do that though. Now, you move your funnel to the new position. And you're going to continue to do this for 30 times. This is the most complicated in terms of how you operate it. Usually students will be confused in the process of finding the new funnel positions, right? Therefore, the method for you to carry out the experiment has to be very disciplined, consistent, and you need to have a very clear way of marking the position of the bean and also the position of the funnel. And sometimes students, if they pay attention to that, they will even try to number each bean position and funnel position. And the purpose is to collect more data so that you will be able to trace, to troubleshoot, to find the root cause, and so forth. So every single detail in the experiment can be used to illustrate how you should manage a system, how you should develop people and lead the system. And rule 3 is to adjust the funnel at every drop, but use the target as the reference point. So you set the target you set the funnel an equal but opposite distance from the target. And this is more straightforward though. For example, when the first bean drop here, and you adjust your funnel to the opposite direction. And the second bean drop here, and don't care about last funnel position, you just adjust the funnel the opposite direction, and that will be the new funnel position. And this is rule 3. Later, I'm going to show you all the results that I collected from my students, okay? We also want to show the 3 teams, waiting workers, what they produced. And we're going to demonstrate common causes and special causes, right? You will be able to see the results of the students that I just did it probably a month ago with my latest class of the MBA students, okay? Can you see it? Oh, let me. Okay, you can see this is just the class that I taught recently. And this is the distribution. You see that I have 12 teams in my typical class. If I have 40 plus students, and I'll divide them into 12 teams, and T represent this target, bullseye. And ring 1, 2, 3, 4, that moves away from the target, and out means that it goes beyond the target, right? And as you can see, each team has different setting in terms of the funnel size, the target, and the length of the string. And in the remote columns, I noted that some of the teams, they actually violated some of the rules. So eventually, I will exclude those teams from my data collection, okay? But you probably can see some general patterns, right? Just from the data here, you may be able to see some general patterns, right? That's different class, and I will not go into detail. I will just show you the summary statistics, okay? But before I go into that, I would like to ask the 3 teams on the stage. Maybe they can share with us some of these questions. How do they respond to some of these questions? For example, when you did that experiment, did you observe any particular pattern? And how can that be improved? If you're going to do it again, how can it be improved? You know, maybe each of the 3 teams can share briefly with us. TJ, want to go first?
Yeah, sure. I think it can be improved by using shady auditors. But joking aside, we were lucky because we had a very short string, which
Yes.
means we were closest to the target.
That's right.
What we found is heavier beans are easier to control. The lighter beans somehow were outside of the target a bit more. The heavier beans were almost on top of the target. So one way of improving would be to go to the supplier and get heavier beans. So we were on target on 23 times out of 25. Sorry, 28 out of 30.
28
I've been giving wrong information. Yes.
I was wondering whether the other 2 teams, do you have any things to share?
So we were set up. We had rule 2, and that was the most hardest one for us to do. Our team, it was very difficult to actually get the bean inside it. We were, as you guys can see, we were all over the place, and we were constantly doubting ourselves whether we got it right or not. And I'm going to ask Diana to kind of brief more about why.
I agree with TJ, though, with the beads. It was very hard to actually see where they hit, but some, because of the weight, were easier than others. Others would bounce right off the sheet. We did find with the string, our string was longer, so it was harder. It was more difficult to control.
It was very difficult for
And
us
this
to-
ruler is close to impossible.
Okay, yes.
You see, the closer it started like falling into the target, it was harder for us to actually measure it.
Yes,
Because we didn't know whether it landed in the same spot or a different spot.
yes. So there's some difficulty in the measurement itself. And, right? Accuracy, right? In terms of the accuracy, it could be a potentially problem, right? When it comes to decide whether your distribution is good or not, right? Okay. Now comes to Team A. Stephen, do you have any observation?
My observation amongst my colleagues here is I'm an incredibly good bean releaser. I had no idea I had such a skill inside of me. But Tripp, why don't you share your thoughts? I was afraid to fail. Bottom line, I was afraid to fail, and I think I did okay.
Well, we had the rule 3 where you started at the center, where it dropped, then we have to go exact opposite, keeping the center between, equidistant between the next drop. So what we found is it went everywhere eventually. It kept getting uglier and uglier. So that's the design that we came up with there.
Do we have the summarized? Okay, let me go into the show. Yeah. Okay. Well, from the results, although I think the first two, Team A and C, they finished all 30 beans, right? Okay. Team B was not able to finish all 30 beans. As I said, it's more complicated. It is more difficult because you have to adjust. So they ended up finished 10 beans, right? Yeah, it is okay. Now, I think at this stage, we're going to thank them and maybe, allow them to sit back to their stage. Okay, thank you very much. What I'm going to do next is to show you the statistics that I collected over the past 10 years from different groups of students. And the most important lessons that I hope to demonstrate is to show how we can use this experiment to explain Dr. Deming's 14 points and the expanded funnel experiment. Okay. Now, the waiting workers result for Team A, you can write it down though. T is 10, and ring 1 is 8, and ring 2 is 2, ring 3 is 7, and ring 4 is 4, and out is 5. That is Team A's result, applying Rule 3, right? And Team B, they did not finish all, but they have 5 in the target and 5 in ring 1. And Team C, they have 27 in the target and 3 in ring 1. Well, although they did not finish, Team B did not finish, but it already very clearly demonstrates the effect of these different factors. Right? And which teams were tempering? Which teams were tempering? Applying Rule 2 and Rule 3, right? So Team A and Team B, they were tempering throughout the whole process. They adjust the funnel without knowing the real reasons. And Team C is the only team that remained constant, right, in holding their funnel throughout. Of course, they are also given a small funnel, short string, and larger target. So I will anticipate all 30 beans hitting the target. You just hit 27. Okay. No, you cannot tell because the beans are different, right? The experimental result that I'm going to show you is the data that I collected from 2012 to 2014. But prior to that, I already done this experiment almost 10 years. And I only collect the more recent data because these are the ones using the consistent settings. In the early years, I still trying to figure out what's the best way to conduct the experiment. So there are certain experimental settings were changed or fine-tuned. And I only collect the data, use the data for the most recent 3 years, and to show you. And this is from my MBA and executive MBA, and also the general management program, executive classes. So more than 1,000 of students have done this experiment in my class. And I always told them that you cannot get this anywhere else. No other business school will teach so much about Dr. Deming's teaching. And this year, I even decided just to use Dr. Deming's books as the reference text, not the typical operations management text, and use that as the foundation to teach all that I want to teach in this short course. In the data that I'm going to show you, I eliminated some of the outliers groups. These outlier groups are the ones that I show you that I have remarks. They did something wrong, obviously, did not follow the rule throughout, so I consider their data of no reference value, so I excluded those groups, okay? And I collected 60 groups. Let me show you some of the results. This is from one of the more recent class, right? The funnel size is large and string 30, rule 1. This is distribution. The same group used rule 2. The same group used rule 3. Okay, this is the same group ABC, right? Use rule 1, 2, 3. Right? You can see the distribution. The changes is very obvious. Now this is another group, right? Team 7. And use rule 1, rule 2, and rule 3, right? And you can see consistent patterns, okay? Now let me show you something else, right? Theoretically, you probably will find that rule 1 will have this type of distribution, and rule 2 will be like this, and rule 3 will be like this. Usually, it will scatter along a certain axis because you're going to move your funnel, right, in the opposite direction. Frequently, when you move, it will move beyond. By the way, Stephen's team, A team, did you? Oh, yes, you have 5 beans drop out of the target, right? You have 5 beans. That is not too many, though. You look at this team. This is the outcome, right? Of course, the cross, only the cross are the bean position. The circles are the funnel position, right? So you can tell that almost half of their beans drop outside the target, even though their target is bigger target, is an oval target, right? Well, this team is even bigger. So one piece of paper is not big enough. They need to use 2 pieces, additional pieces, to extend, right, so that they can record. Now, this team is even further, right? Once they swing along that axis, they will never be able to come back. And we see that in organizations. This is not exaggerating. We see that in organizations, but just that they don't know what's going on, right? Or maybe they think that, well, I will change my job, right? Or the person will be replaced very soon, right? So you did not have the chance to see all the stringing, right? Now, in Dr. Deming's book, Out of the Crisis, page 328 has this diagram. Shows theoretically when you apply the 4 rules, and this is how the distribution would look like. And I think our experimental results is also very close to this, right? in fact, it can empirically prove that this is the distribution. And now I summarize them in statistic manner, right? So this is the expanding funnel experiment. This is the average number of the hits in each ring. Earlier I said that this is based upon 60 groups, right, of the data. And each of this number is an average of 10 groups, an average of 10 values, right? And you probably can easily observe some patterns, right? From target moving away from the target, ring 1 and out to 4. And as you move from rule 1 to rule 2 and rule 3. And you can imagine, funnel is just like the machine or equipment that you used. And the target is the customer specification or the customer requirements. And the height is kind of like the method that you used within your organization, right? And the rule would be like the decision or policies that you have within your organization. So when you manage by results only, then you will tend to behave like rule 2 or rule 3. Oh, this is a mistake. This should be 3. Rule 2 or rule 3, right? This is 1, 2, 3. Okay. So here you can see very clearly there's a clear pattern as you move down, right? Oh, no, this is the standard deviation. Okay. As you move down here, you can see that there's a pattern. This number gets bigger and gets bigger, right? And as you move across the column, and this gets bigger outside. Gets bigger from rule 1 to rule 2, rule 3. It corresponds to the same ring of the target. Now the next table shows the standard deviation. Table 1 is the average, and table 2 is the standard deviation. And you can see that it follows the similar pattern. But for the small funnel, you can clearly see that the standard deviation of these outer rings are very small or close to 0, because it probably rarely happens in the outer rings for the small funnel, for the short string. But for the large funnel, large string, you can see the standard deviation remain big, even, right, in these outer rings. It will probably take a little bit more time for you to look at this data closely to digest. Okay. Now I'm going to quickly summarize the effects of each of these factors. The effect of the size of the funnel, as I said, it can be compared to your machine or equipment. You can see that the smaller, the more focus. A smaller funnel, if your system is like a smaller funnel, then you can expect the result will be more consistent, right? And tend towards the bull's eye. That is reflected by the mean of the distribution, right? And the standard deviation. You can see that. The similar pattern for both, regardless, either circular or oval targets. Okay. And how about the effects of the shape of the target? As you can see here, right, you have identical setting except that the target is of different shape and dimension. The oval shaped target is just bigger, right? I just stretch it a little bit, remain the same height, stretch a little bit, so it is bigger in terms of the areas that it covers. And that can represent that you are dealing with a customer who is kinder, give you a more generous spec, right? Okay. So the bullseye represents the idea of the target, right? And as you move away from the bullseye toward the outer rings, it represents the performance deteriorates or deviates further from the ideal state, right? If the bullseye is the ideal state, and you move away from it, is that you deviate, right? Although still within the target, but it may not be desirable, right? And beyond the outermost ring, that means that it is no longer acceptable to the customer. And when you are applying rule C, like the team A did, right? You have the large funnel, and you have that small target, then you are in a serious situation, right? It's very difficult for you to consistently to meet the target or customer's requirements. And how about the effect of the string length? That is equivalent to your method or how you execute. And that is equivalent to the level of consistency or precision of your execution, right? The shorter, the more consistent. That is quite intuitive, right? The best is that you probably just attach your target, attach your funnel to the target. That is the most ideal. That you will not have any variability, right? That is even far better than Six Sigma. Okay. How about the rule, the effects of the rules? That is kind of like your decision or policies. Rule 1 represents constancy of purpose. You remain focused on what you are doing. And Rule 2 represents the decision or policy that is made hastily, often in reaction to visible changes in the outcome, and with the memory of what has just happened or done earlier. And Rule 3 is similar to Rule 2, but it has no memory. Every time I just move with reference to the bullseye and move to the opposite direction. Right? And we see how people make decisions in typical organizations resembling Rule 2 and Rule 3 often. Right? The dispersion generally increases, as I show you in the data, from Rule 1 to Rule 2 to Rule 3. But it's interesting to see that the impact of the rules varies depending what kind of system you are operating on. It is notable that the impact of the rules on different funnel settings is different. That says a lot about how you should develop your system, how you should manage your system, right? But more than that, there are interaction effects among these factors. This is a really complex dynamic system. The complex dynamics that we can see as a result of the interaction among these factors really represent what we saw in the real world, making decisions and the actions taken by any organizations. The same policy has different impact depending what kind of system you have. For example, the effect of Rule 2 and Rule 3 on the mass distribution is more prominent in a system of larger funnel and longer string. This is the aha moment for most of the students. They never realized that this is so obvious until they work on this experiment. With the small funnel, regardless what kind of rules you use, the deviation will not be big. It will remain small. But for large funnel, you change the rule, and the deviation that will amplify significantly. The concentrating effect produced by a smaller funnel is somewhat offset by using Rule 2 and Rule 3. So if you have a system equivalent to small funnel, and you don't make a decision like Rule 2 and Rule 3, then you are in a very, very good shape, very ideal state. Now we can look at the interaction effects from two additional angles. One is from supplier's perspective, and that is the interaction between the funnels and the rules. Funnel is the system, is the service provider, is the supplier. You are managing your system to provide service, okay? So what if you have Rule 2 and Rule 3? Actually, Rule 2 and Rule 3 are much more disrupted in a system of a larger funnel with longer string, as I already explained earlier on. Now let's look at from another perspective, from customer's perspective. That is from the target's perspective. Target is provided by the customer, right? The interaction between the targets and the rules, it has the reverse effect of Rule 2 and Rule 3 on the target, on the mark distribution. It is more obvious in a system of a more stringent target. That means that if your customers are more picky, right, provide a more stringent requirements, and now you're applying Rule 2 and Rule 3 as a supplier in your system, then you are more likely to get yourself into trouble, right? Because customer has more stringent requirements. On the other hand, your system is operating with Rule 2 and Rule 3, making decisions or making policies without knowing what you're actually doing. You are tampering all the time, right? So you can see the poor decision or policy making is very costly in this case. In reality, poor decision and policy making will certainly anger or frustrate a customer of higher expectation more easily, right? Okay. Now, how about special causes and common causes? This is illustrated very clearly. Rule 2 and Rule 3 represent tampering system, making adjustment without understanding the true causes. And special causes would be like how the funnel is handled, how the string is handled, or how stationary the target is relative to the funnel. How beans are released into the funnel. Sometimes I will observe students will throw the beans. Sometimes they will take turns to release the beans, right? Sometimes there were different people to record how hits are observed and marked, okay? And these are all special causes. And how about common causes? The funnel size, the string length, the target shape, dimension, and bins, these are inherent to the system. So these are the common causes, right? And the rules adopted, it can be considered either a common cause or special cause. Okay. Now, how can we use this to illustrate 14 points? I don't think I have time to go through each of these points very clearly, but you can refer to my paper, right? It has full description of all this, right? But I'm just going to highlight a few of this, and that will become very clear. For example, let's look at this. Create constancy of purpose toward improvement of products and service. Now, the insights we get from the expanded funnel experiment, and this bold-faced italic font, these are the typical comments that I heard from my students when they do the experiment, okay? Well, they will try different rules or deploy different person to hold the funnels, right? The experimental setting must remain consistent throughout the experiment rather than alternating roles, shifting targets, changing funnel height, or marking spots inconsistently. There is more that we can say about this. Because of the space and time constraint, I do not have other put into this form. Right? Now let's look at another points here. Point number 5: improve constantly and forever the system of production and service. Sometimes I hear comments something like this: "Come on, that between the team members, they sort of trying to encourage or blame one another. You aim more precisely, right? You throw the bean more gently, please. You know, some team members, they just throw, you know, yeah, throw this. Yeah. Now, specific to this experiment, the experimental outcome can only be improved by reducing or eliminating special causes and common causes. In general, that we learned from this experiment is that the Deming chain reaction, where a focus on quality and improvement will result in better economics, jobs and more jobs. And that is leaders' job to reduce the funnel size, to reduce the string length, right? Or even to remove the string. And that is the leader's job. That is called continual improvement. Now, one more point here is about dry out fear, right? According to Kelly, this is something more difficult. What happened to your hands? The funnel is not aiming properly. Again, one of the members shouting out to the other members, right? Quick, or we may not have the break. Right? Usually, all the 3 experiments would take about 1 hour, and sometimes this is between the break, right, and their experiment. So if they did rule 2 wrongly, they have to repeat for additional 20 minutes. So this comment is quite frequently that I heard from students. Now, blaming the culture or the people, establishing arbitrary numerical goals, incentives, or zero tolerance for failures will drive group members to misrepresent the data. So sometimes they will cheat. They will not do all 30 beans, but they will produce all 30 spots for me to record. Yes, okay? Therefore, the data collected will not reflect the true outcome. Even if they faithfully finish all 30 beans, just based upon their experience, Diana earlier shared that it's very difficult to have accurate records of the bean drops because it's so fast, right? So what we saw is not actually, right? Okay. In general, fear can be damaging, right? Harm people, harm the organization, and it causes dysfunctional behaviors. Okay? Now, 10 and 11s, you know, according to Dennis, this is difficult, right? Now, eliminate, you're going to performance, evaluation. But you know that, you know, if you can hit 5% more on the bullseye than the other 2 groups, and we're going to win. You know, you will not be able to do much better than Group C because they have small funnel. There is no way Group A going to beat Group C. No way. The systems are different. Okay? So I have more and more here. So I think I'm going to let you to read the article, the paper, to get all the details, right? Because of the time. Now, I'm going to quickly just highlight how can we use this experiment to illustrate Dr. Deming's system of profound knowledge. Now, this system consists of the funnel, the string, and the target, the beans and the markers, and so forth, okay? And those are the factors, right? It will be affected, and the result will be affected. And the second evidence, knowledge about variation, is clearly illustrated that special causes and common causes, okay? And the theory of knowledge, right? There is really no true value of the location of a mark. It also depends on the operational definition of hitting the target or marking the spot. And we need theory. We need know why. We need know what and know how. Otherwise, the interpretation of the data collected will become meaningless. So does prediction becomes meaningless. Okay? Psychology, fear, among the group members, the interpersonal dynamics among those funnel holders, bin releasers, those using larger funnel, smaller funnel, and the incentive policy and so forth will affect the behavior, okay? There are some additional insights. That is more than what I can talk, okay? Now, on deadly disease, and I will let you read the article, and you can see this. If you just look at the number, right, distribution 5, 8, 10, 6, 1, and 6, 9, 10, 6, 1, looks similar, but their distribution is very different, right? Distribution very different. But if you only look at number alone, you will be deceived. Then how about Six Sigma? As you look at these three, it clearly demonstrates, right, based upon the 14 points, what you are trying to do, and this is what Six Sigma hope to achieve, to make it more consistent. How about balanced scorecard? This provides a lot of reasons why typical organization will fail, okay? Finally, this experiment incorporate these elements so that it make it real and can demonstrate Dr. Deming's teaching graphically. The experiment of expected funnel experiment clearly demonstrated that a more robust system is significantly less sensitive to an external or internal shock. And with Deming's system of profound knowledge as the framework and use the 14 points as the guidelines, I think organization can really embark on a genuine transformation journey. Thank you very much.